So I'm going to work a couple of the odd problems on page 125. Look at number 4. Negative 5x squared plus 4x minus 2 plus negative 8x squared plus 2x plus 1. Just as a review, are these polynomials? What are the rules if it's not a polynomial? Negative exponents on variables. No square roots over variables. No variables in the denominator. No fractions or decimals, or no x in the exponents. Okay, so these are both polynomials. So we have a trinomial, and we're going to add that to a trinomial. How do you add two polynomials together? You just combine like terms. Does x squared have a match? Yeah. What is negative 5x squared and negative 8x squared? Negative 13x squared. Does this x have a match? It combines. Wow. It combines with the 2x, and I get 6x. And then the constants, negative 2 plus 1, would be minus 1. Easy enough, right? Okay, look at number 6. 8x to the 4th plus 2x squared minus 1. We're going to add that to 3x to the 3rd minus 5x squared plus 7x plus 1. Okay. Does x to the 4th have a match? No. Does x to the 4th have a match? No. There's no like term. So 8x to the 4th. What's next? I need to do the x to the 3rd. So there's an x to the 3rd over here that doesn't have a like term like this. Now I can do the squares. 2 minus 5 is negative 3. And then there's an x here. And then my constants end up turning into 0. Okay, does that make sense? That's addition. What about subtraction? Take a look at number 10. 7x to the 4th minus 9x to the 3rd minus 4x squared plus 5x plus 6. And I'm going to subtract 2x to the 4th plus 3x to the 3rd minus x squared plus x minus 4. How do I subtract one polynomial from another? It's a little bit different. I need to distribute the negative. So I take my original polynomial and I'm going to subtract all of these, which means I'm going to distribute this negative into every term. So this would be negative, positive, or sorry, negative. So that one will be negative, this one will be positive, this one will be negative, and that one will be positive. And then I can just add them. So when you're subtracting polynomials, you're going to do the opposite of what's in the second polynomial. If it says minus 6, you're going to add 6. If it says plus 9, you're going to subtract 9. So does x to the 4th have a match? Yes, it used to be positive 2, but we're subtracting. So now we do 7 minus 2 is 5x to the 4th. And then negative 9 minus 3 is negative 12x to the 3rd. Negative 4x squared plus x squared is minus 3x squared. And 5x plus x is 6x, and 6 plus 4 is 10. Does that make sense? Okay. And now multiplication. If I had 4x squared times 2x squared minus 6x plus 10, what do I do? I'm going to distribute this 4x squared into every term. 4x squared times 2x squared would be 8x to the fourth. You multiply the coefficients and you add the exponents. Multiply the coefficients, add the exponents. 4x squared minus 6x is negative 24x to the third, and 4x squared times 10 is plus 40x squared. Do you remember that? All right, what about 4x minus 3 times 2x plus 5? I multiply these in the box. I draw a 2 by 2 box, 4x minus 3 and 2x plus 5, and then I just fill in every box using multiplication and then simplify when I'm done. 2x times 4x is 8x squared. 2x times 3 is negative 6x. 4x times 5 is 20x. And 5 times negative 3 is negative 15. Are there any like terms? If there are like terms, they're probably going to be right here. That's not true every time, but most of the time they'll be in that along that diagonal. 8x squared plus 14x minus 15. Does that make sense? What if I add 2x minus 1 times x squared minus 6x plus 2? Same idea, but now my box is a different shape. It has 3 on one side and 2 on the other. Does it matter if I do a 2 by 3 versus a 3 by 2? No. You'll just multiply them in a different order, but when you simplify, you're going to get the same answer. All right, what if this first one was a trinomial? Now it will be a 3 by 3 box, and when I multiply, these will probably be like terms, and these will be like terms, and these will be like terms. Usually. That's usually what happens. If your polynomials are in order, like x squared, x constant, and you don't skip any, so 2, 1, 0, if you had like an x to the fifth plus 2x to the third, I'm missing a fourth, then they might not line up inside the box. But if you have every term and you don't skip any terms and they're in order, then the diagonals will be your like terms. I think that's probably going to happen every time today. Okay. What if I had x minus 4 times x plus 2 times x minus 1? How would we do that? Well, let's pretend that this doesn't exist. If I had 2 times 4 times 3, how would you do that? 2 times 4 is 8, times 3 is 24. So the idea is figure out those. Once you know what those multiply to be, then bring in the last one. Let's multiply these together and forget that that last one even exists. X minus 4 and x plus 2, x squared minus 4x, 2x minus 8. That turns into x squared minus 2x minus 8. Right? Okay. Now what do I do? Oh, really? Now I bring in this x minus 1. I put the x minus 1 right here. And then I multiply again. X squared minus 2x or x to the third minus 2x squared minus 8x and negative x squared plus 2x plus 8. And then notice the diagonals are lined up. X to the third minus 3x squared minus 6x plus 8. Does that make sense? So if you have three binomials to multiply together, just deal with the first two, and when you're done with that, bring in the third one. Okay. Your problem set is going to be 3.2, 3 through 70, 75 odd, but today I want you to stop at 41. Stop when you get to 41, and we'll finish the rest of it on Wednesday. All right? Good luck.